Hi, and welcome to Mathematics with Tom. I am Tom, and today we're going to talk about what are called indistinguishable permutations and combinations. So, let's take a look at what we have to do today. And let me find my chalk. Oh, there it is. Okay, let's get started. Come to the chalkboard. What do we have? So the formal thing that we're going to be looking at are called indistinguishable, permutations and combinations. But I'm going to call today's lecture Learn to See. Learn to see. That's what we're going to do today. We're going to learn to see. And again, we're going to be counting. Permutations were ways things could be ordered. Combinations, you'll see, are the same idea. And so all of these problems open with one simple question. And the question is how many ways? How many ways? And in this case, how many ways can the letters, now I'm going to write it this way, how many ways, ... But today we're going to do something even more specifically, and we're going to be specific in this how many words, how many words can be made, how many words can be made. I'm going to put how many words, that'll work. How many words can be made? Question mark. And words has a unique notation. In mathematics, a word, let's come over here. A word is an arrangement of symbols. Symbols. And a symbol, these could be numbers, letters, or just any character, any symbol. Okay. So it begins with 2. How many words can we make from 2? Well, let's think. We're going to do this. We need to do some experimenting or a little bit of thought. So if I have the word 2 and I want to say how many ways? Well, there's not a lot that can happen. You can put the T in the first position and the O in the second position, or you could put the O in that's really big. Let me rewrite that. So 2. Or you could put the O in the first position and the T in the second position. So we can see there's two ways or two words that can be written from two symbols. And another way to have done that is we could have said, well, there's a first symbol, there's a second symbol. I choose one of the first two, so there's two symbols that could go in the first spot. Then I've used up one of those symbols, so there's only one symbol that could go into the second position. We multiply, and our result is 2. I'm going to write this way, 2 factorial, which is also 2. Okay. Now, let's see if this makes sense. I'm going to come over here, and let's start with C, S, E, A. C. You may not have been expecting that version of C. Well, I would like that we can get to the answer quickly. We know how, but I want to write something out so that you can, and then we're going to recreate it. There's something more that needs to be seen. Notice this. So I'm going to start with S again. And then I'm going to switch the second two letters. So that's going to be A, E. Okay. Then let's start with the E, the second letter. And then we'll just go first and third. So we'll go S, A. Again, we'll leave the first letter in place and switch the next two. A, S. Finally, we'll start with the A, S, E. And then we'll come over again, we'll start with the A and switch the second two for A, E, S. I think that's all the ways we can arrange these letters. This is all possible words. And remember, in mathematics, a word doesn't have to be something in the dictionary, okay? But we could have done this by saying, all right, I have three symbols. 1, 2, 3. So of course you would draw a picture. I like drawing pictures. So draw a picture if you're not sure what to do. And then you would go through this process. How many symbols could go into that first position? And the answer is 1, 2, 3. All right, can we use this? 1, 2, 3. So we'll put a 3 here. So then we choose a symbol. Maybe we chose the E. Now, when I come to the second position, there's 2 symbols. Say I picked the A. Then I would come to the last position. There's only 1 symbol left. And so I have 3 times 2 times 1, which is, now I'm going to write this out. It's 3 factorial. It's also 6, which is 1, 2, 3, 4, 5, 6, which matches with what we figured out. Okay. Now, let's see if we're ready to see. Let's come over here. All right, so let's see. S, E, E. Okay. Now let's go through the exact same process that we did here. Here, what did we do? We started with the first letter. That was an S. And then we switch these two. Well, let's switch these two, and what do I get? I get S, E, E. Okay, let's keep going before we come to any premature conclusions. So then we said, let's start with the second letter, and then first and third. So that would be the second letter, the first, and then the third. But then what did we do? Well, we switched the last 2 letters for E, E, S. And then we started with the third letter, that's an E. And then we went first and second, And then we rewrote the first and switched the second too. It's following the exact same pattern that we did there. And look at what happens. Look at that for a moment, because notice this. We have two C's. We have two easies, and we have two E's. Why is that? It's because these two E's can be arranged two ways. When we put the S in the second position, these two E's can be arranged two ways, 2 factorial. And when we put the S in the third position, the two E's again have 2 positions. So here's what we do. So in other words, we don't need this. This is the same thing. EZ and EZ, we only need one of those. And we only need one of our E's. So the answer is not 6, it's 1, 2, 3. So there are the answer is 3. And how do we get it? It's on the board. Let me show you. Here's what we do. We write different. Let's call it different. And if all of these were different, this is like SEA, there was 3 factorial ways to write that. We'll write it in this. Okay, but they're not all the same. Those E's copy themselves how many times? 2 factorial times. So what we do is we want to divide by our repeats. That's the answer. We know, now let's write this out. This will be for good reason. 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. You can see that what cancels here, and we have 3 as expected. Okay, but we're not done. Let's try. Let's try one more, making sure I've got my screen available. Let's try one more. You know what? It seems easy, doesn't it? That's it. Let's try. Let's see how this seems to really work out. SEES. And again, the question is, how many words can I get from seams? So, we're not going to write it out. I would encourage you to try. Now, if all of those letters were different, that's 1, 2, 3, 4, 5. That's 5 factorial. That is 120 different words. So we're not going to write this out. At this point, we're going to follow the mathematics. Well, so here's what we do. We're going to do this exactly the same way. If all of those were different, then I would have 1, 2, 3, 4, 5. I would have 5 factorial different words. Okay, but they're not all different, are they? I've got repeats. I have repeats. Well, what do? We divide by the number of words that the repeats themselves create. Well, look at that. There's 2 E's, and we know how many words. Those in themselves create 2 factorial words. Oh, and there it is. Look at this. We also have 2 S's. So they're going to create 2 factorial words as well. Okay, we're going to run through this a few different ways, and I'll show you why. So this is equal to 5 factorial, that's 5 times, 4 times, 3 times, 2 times 1. Take and divide all that. Now 2 factorial is 2 times 1. And notice I didn't write a times sign in here. If you don't have to, but if you wanted to, you could. It's usually implied. The factorial will mean separating the twos. Times 2 times 1. And then, 2 times 1 times 2 times 1, that's 4. That's a 4. So my problem gets reduced down to 5 times 3, that's 15 times 2, that's 30. Okay. Now, I want to go over a problem. So here's a concern, and it's incorrect. And I'll show you why. Suppose we start here. We have 5 factorial divided by 2 factorial, 2 factorial. And then in your calculator, you type 5 factorial, and then you hit divided, so you hit the divided button, 2 factorial, 2 factorial. So you might enter those keystrokes. It might also display on your calculators 5 factorial divided by 2 factorial, 2 factorial. I would encourage you to try this. But I think you're going to get the wrong answer. I want to show you why. Here's why. Because if you recall, order of operations. The order of operations for, I'm going to abbreviate for multiplication, M-U-L, that's my abbreviation for shun, multiplication and division is left to right. It's for, and let's put this, a sequence of, there, for a sequence of multiplication and division is left to right. So what does that mean? That means you would take 5 factorial. All right, well 5 factorial, we already said is 120. You would divide it by 2 factorial. So you divide it 120, you divide it by 2, that would be 60. But what's this? This is multiplication. This is going to take your 60 and put it back up to 120. And you're off. You should get 30, not 120. So how do you fix that? And the correction I'm going to show you as soon as I check that I'm still on the camera. Correction for the calculator is, and let's write it out, it's at 5 factorial, I'm just writing the problem again, divided by 2 factorial, 2 factorial. In your calculator, it looks like this. It's 5 factorial divided by, then you have to use a parenthesis, 2 factorial times 2 factorial. And again, if you wanted to put a multiplication sign, you can do that. So it's usually not necessary. But I would run a few checks and make sure that that works as you expect. All right? So you can type it this way, or it might look like 5 divided by parenthesis 2 factorial times 2 factorial parenthesis, and then you should get the correct answer. I told you I was going to talk about combinations in this one, but I think this has gone far enough. So in the next one, we'll talk about combinations. These are indistinguishable permutations.